by the way, it's for a different project. Okay, so my project is around man versus machine. Who is better at finding objects? Is it computers or is it humans? Okay, so humans and computers tackle projects very differently from one another. And I thought, what better way than tackling this problem than as a 35-year-old children's book called Where's Wally? So, how can a computer find Wally? First of all, they use something called a convolutional neural network, which is a CNN for short. You pass it a variety of images, and the computer looks at the nodes, edges, and different properties of the image and tries to do a bit of a guesstimate to where it is. I wanted to build my own, so first I brought my camera and went to the Liverpool City Centre Library, which is roughly 30 minutes one of these directions. And I decided to borrow 19 large-scale images of the Where's Wally books. And my model performed, well, terribly. But I thought, maybe it's around how many data sets I used. So I went online and downloaded thousands of images of Wally. And surprisingly, it did actually way worse. So instead of that, I wanted to use just the base image of Wally himself to see how well it could do. It did find him with a 90% accuracy, but it took around 20 seconds. Now, I'm not sure if you've ever read the Where's Wally book, but they're very complicated. So this solution is not very practical. So we have to go back to the drawing board and come up with a different solution. The solution I came up with is using a jigsaw puzzle approach. With this method, imagine, I'm just going to have to wait a second, the Coca-Cola logo that you'll see behind me in a second, picture that as a jigsaw piece, and the Coca-Cola bottle as the large final image of the jigsaw, and you're telling the computer, try find where this jigsaw piece will fit in the jigsaw. And this solution is perfect if you know exactly what you're looking for. And in our case, it will be, in a second that will show up, a mugshot image of Wally himself. I use Python for this code, and if you ask nicely later on, I might be able to share this information with you. So how did this solution get on? Not only first that it found Wally within around 3 seconds, it was faster and way more reliable than the CNN approach. So we have 3 seconds to find Wally on a computer. How can a computer fare up? I'm not sure about you guys, but when I try find Wally, I kind of just dart around the entire page until I find somebody with glasses similar to mine. So I found a report by a guy called Randall Olson, and what he did was first found all the locations of where Waldo is on the page. It's Waldo, by the way, because this guy is an American. And he created a kernel density estimate, which is kind of like a heat spread map of where Wally should really be on the map. Based on that, he used something called a genetic algorithm, which kind of gives you a rough path of where you should be looking to find Wally. Now, a fun fact about genetic algorithms is that the Kyoto, Japan railway station used a genetic algorithm to try and improve their railway service. If only Mersey Travel could learn a thing or two. So, but cross-referencing this image was taking too long for me to flip back and forth. So I wanted to create a stencil-like tool to try and help me, similar to what you would get in primary school. So after a couple bits of 3D software and using one of the largest scale Liverpool 3D printers, I created this little device to try and help me. You put this on the double-sided page and you kind of follow your finger across and hopefully you can find the solution. Now, this is good, but still, comparing to a 3-second computer is really hard. So I tried to tweak the challenge a little bit. Instead of the original challenge, I changed it to be the first person to find and circle Wally, introducing the pen plotter tool. Now, what this does is hopefully give the humans a bit of an edge, because the computer now has to try and find and circle where Wally actually is. This is in black and white, by the way, because sadly I do not have the funds for coloured print anymore due to inflation. So, what is the $1 million question? How fast will the humans work compared to machines? With the computer, taking the code, uploading it, and then transferring it to the pen plotter, which will circle out every single solution, took around 1 minute. And for the humans, even with the stencil-like tool, sadly it only took 2 minutes. And judging by everybody's faces, nobody's surprised. However, we did have some lessons that we learned from this. The main one being, just because a solution is more complex or sounds sophisticated, just like the CNN approach, doesn't mean it is the right one. The jigsaw approach is more simple, but is way more efficient. Not only that, here's a little shameless plug, I created a full large-scale video on this that you guys can see on my YouTube channel as well. So if you want to see more problems, because there was a lot more problems than just the 5-minute presentation, you can see it there. And I'm on all these different platforms as well. If you have any questions, I'm happy to answer them on there. So, thanks.